In these problems, we're being asked to determine if numbers are prime or not. Prime means that they don't have any other factors other than just 1 and themselves. So for example, the number 2, the only numbers that multiply to make 2 are 1 and itself, 1 and 2. There's nothing else, no other whole numbers you can multiply to make a 2. So 2 is prime. And in the same way, 3 and 5 and 7 are, and 11, those are the first 5 prime numbers. And getting to know that those are prime, that's probably a good idea. One thing you'll notice, they're all odd. An even number, except for 2, of course. Other even numbers are not going to be prime because they'll be divisible by 2. So, but how do you know if a number like, I don't know, 21 or 29 or 31 or 33 is prime or not? One way you could try is you could just try dividing it by everything. Divide it by 2, divide it by 3, divide it by 4, divide it by 5. If you never get a whole number, then it's prime. That's a lot of work, though. So I'm going to show you a little technique that this guy named Eratosthenes came up with a few thousand years ago. And since I noticed in these problems, it's only going up numbers up to about 30 or so, and it's a really quick way to find prime numbers using Eratosthenes' method here when you don't have a whole long list to get to. Basically, now 1 is just a special thing. It's sort of neither prime nor not prime, so we're just going to ignore 1. And then we know that 2 is prime, and 3 is prime, and 5 is prime, and 7 is prime, and 11 is prime. Now, what we're going to do is we're going to use our smarts here to say that, well, if a number has 2 as a factor, then it's not prime, right? If it's divisible by 2, it can't be prime because it's got 2 as a factor. So all of these even numbers greater than 2 can't be prime numbers. So 4 is divisible by 2, 6 is divisible, 8. And I'm just going to go through here and cross out quickly all of these numbers. And what you can see is right away, we are eliminating half these numbers from our possible primes list, which is what we're making here. We're making a list of primes. Okay, so we got rid of those divisible by 2. Now we're going to go and do the same thing for divisible by 3. So I'm going to count by 3s here. 3, 6, that's already crossed out. 9 is divisible by 3. 12, 15 is divisible by 3. 18, 21 is divisible by 3. 24, 27 is divisible by 3. 30, 33 is divisible by 3. 36, 39 is divisible by 3. Okay, we're done with the 3s. And let's see, I'm going to do the same thing now with 5. So if it's got 5 as a factor, it can't be prime. And I'm just going to look through the list here. I've got 11, 17, 19, 23. There's 25 and 35. Those are the only ones left. Now, my next question is there anything divisible by 7 here that we haven't crossed out already? 7 would be 14, already crossed out. 21 already crossed out. 28 already crossed out. 35 already crossed out. So we're done with that. And actually, we've done it for this portion of the list. If your list was a lot longer than this, you'd have to go up to higher numbers. But we've got now the first bunch of prime numbers up to 40. So in addition to 2, 3, 5, 7, and 11, we've got 13, 17, 23, 29, 31, and 37. So those are the ones we'll be on the lookout for. And really, it took us 2 minutes to do this. So if you're not sure if a number is prime, you can just make a list and bust out this method from good old Eratosthenes. All right, so put a check by all the prime numbers. 7, yes, that's prime. 17 is that on our list? Yes, that's prime. 20 I know is not. It's divisible by 4 and 5. 21, that's divisible by 3 and 7. Oh, why did I put a check there? So not prime. 21, not prime. 25, divisible by 5. Clearly it's got a 5 at the end. 29, is that on our list? Yeah, it is. So we've got 7, 17, and 29 as prime numbers. All right, let's do one more set for practice here. 2 is prime. That's on our list. 14, that's divisible by 2. That's an even number, easy to cross off the list. 17 is prime. That's on our list. 20 divisible by 4 and 5, 21 divisible by 3, 24 is even, that's not going to be prime. So in this list, only 2 and 17 are prime numbers. So that is a little bit of work with prime numbers.